energy, about 685 million tons of hydrogen every second is converted into helium, and that's what powers the sun. That's why, you know, my big fat redneck, well, that's why I'm sweating. That's why it's warm outside. You can see light. That's all coming from this reaction inside the sun. Solar wind. Yeah, it's kind of bright, isn't it? Just like the sun. The solar wind is what affects us. The solar wind is part of the sun's atmosphere. We live in the solar wind. We orbit the sun at 92.5 million miles. That might as well be on top of the sun as far as distances in space are concerned. That solar wind hits the Earth's magnetic field, goes around, causes the magnetic field lines to stretch out, and then they bounce back. Anybody ever heard of northern lights? Yeah. This is what causes them. The fields go way out there, and then they pop back in, and they cause northern lights on top and bottom of the Earth's globe, like that. And in 1869, those northern lights covered the entire planet and just vaporized any electrical technology that existed back then. Cut out everything electrical on the entire planet. So back then, there wasn't hardly anything that was electrical, okay? Nowadays, you can imagine what would happen. The sunspot cycles go in 11-year periods, and what this means is the sun's magnetic field is just like the Earth's, but as the sun rotates, the sun is not solid. So different parts rotate at different speeds, and the magnetic fields get twisted. Every 11 years, they get twisted to the maximum, and it causes all these sunspots. Sorry it's so bright, y'all, but that's just the way it is. If you want to turn the lights on, you can. Every 11 years, the magnetic fields get very violent, and they cause more sunspots and flares. And the last one was in 2004, and the next one's in, well, 2002, really. The next one is going on right now. So we're in a period of extreme solar maximum. We're way beyond this point right now. We're up around here right now. Okay? So you're not going to die, and this isn't going to destroy the planet. But you better understand what the sun is, because you'll be seeing it on the news. Has anybody seen anything about the sun on the news in the last 6 months? Have y'all ever watched the news? You ever turn off Real Housewives and turn on the news? Okay. Well, you probably would have seen me if you did, because I'm a real big nerd in this field. So everybody, whenever there's a big solar flare, they come to my house and they want to interview me about what's going to happen. Right now, we are in the 11-year solar maximum, and it's going to last till about the end of 2013. Okay? Earth is subjected to various emissions from the sun that are called space weather. This is a coronal mass ejection. When it hits the Earth, just like in the last slide, it causes the magnetic field to get very disturbed. And it bounces back and causes problems on the Earth. Okay? Now, if you're flying at 50,000 feet in your jet 10 years from now, when all of y'all are commercial pilots, this can kill you. Okay? You have to understand what you're dealing with. They have these things called dosimeters. Have you ever heard of that? That's something you wear when you're. When I was young, I was on a nuclear sub, and I worked in a reactor room, and I used to have to wear these little black things, and if they turned, or they were white, and if they turned black, that means you're about to die, and you had to get out of there. They were radiation meters. When you fly at 50,000 feet or above, you got to wear the same thing, because you can't mess around with radiation. Okay? Not to scare you or anything, but that's just the way it is. In 2003, during the last solar maximum, these are coronal mass ejections coming off of the sun, okay? And the sun's this size. And as you can see, all this interference and everything, this is the standard solar wind out here that's always happening. And that was a big blast that came off. This satellite's 93 million miles from the sun. That blast overpowered the entire satellite. That's the kind of stuff that happens from the sun. The coronal mass ejection will start out here in the lower corona. It explodes, goes through the inner heliosphere, past Venus and Mercury, which Mercury's right here. Then it gets over to Earth, and it just bombards the planet with radiation, dangerous radiation. You know, cockpits now in modern jets are all micro transistors. Back in the 50s, when jets first started out, they had large electronics, like tubes and things. I know this before y'all were born, but back in the day when things first started, one proton, an energetic proton stream, could go right through the electronics in a cockpit, not even bother them, because they were so large. Nowadays, the transistors in your watch or in your phone, they're only the size of one proton. I mean, the whole thing. So one proton going into a transistor that's the size of an atom is going to destroy it and knock out the system. So it's much more important now to understand solar radiation and to be advised when there's going to be a flare that may affect your aircraft. Ooh, how about that? You know what that is right there? This is a close-up view through one of my telescopes of a sunspot that I was watching just last week. And that's an airplane that flew right through the field of view. Now, of course, the airplane is not very close to the sun. I just thought that was cool. There's three kinds of space weather forecasts for solar radiation. Okay, the first one is a radio blackout. The second one is a solar radiation storm, and the third one is geomagnetic storms. They get here at different times. The solar radiation storm is caused by a solar flare. This is an actual picture of a prominence that happened just a few months ago that we saw in our telescopes. The solar radiation storm, that gets here in 10 to 30 minutes, okay? And that is what will vaporize electronics on the planet. Radio blackouts are caused by electromagnetic radiation in the same storm. It takes about 8 minutes for those to get here. Those two things you can't really forecast long in advance because nobody really knows how to forecast flares. We know when there's a higher chance of flares, but it's not to the point where we can say, hey, tomorrow at 3 o'clock there's going to be a big solar flare. Nobody knows when they're going to happen. The geomagnetic storm portion that causes electrical power grids to go out and northern lights, that has about 96 hours warning. So when a flare goes off, we can now forecast with 100% accuracy and say in 4 days from now, the coronal mass ejection is going to hit the Earth and we're likely to lose power. Now, I don't know what we're going to do with 4 days warning, but at least we know that, okay? So if you hear of a solar storm warning on the news, which there's been 2 of them in the last 6 months, it'll give you a level. It'll say G1 through 5 or S1 through S5 or R1 through R5. This is the one to worry about, the geomagnetic storm. Like a G3 or a G4 storm is something you should be concerned with. And what do you do about it? Well, I'm not really sure. Depends on how much you rely on text messaging and internet. If I were you, I would have a backup plan that didn't involve the internet. You know, hey, it might go out for a couple weeks. And let's say there was a powerful geomagnetic storm that came through and knocked out power. It would be different. But you could survive. You just gotta, the key is to understand what it is and know it's not a permanent situation, it's temporary. Okay, so if everybody starts freaking out and putting on their tinfoil hats and stuff and buying all the bread and milk at the stores, just be cool and know that it's going to be over in a few days or a couple weeks at the most. But the key to this is understanding what we're dealing with. Has anyone ever heard anything about any of this before? You have? Yeah. Hardly anybody's ever heard of this kind of stuff, but this is the way it is. And the reason we never heard of it is because we haven't had a storm in the last 40 years. And we may not have one this time, but we haven't had one important enough to even make the news. So hopefully that'll be the case this time. But just in case we do get some warnings, you'll know what they're talking about. How does it impact aviation? Knocks out satellites, basically. This is a very complicated slide. But basically you're going to lose satellites and you could possibly lose electrical power grid, which means no electricity, which means no nothing, right? Internet, any of that stuff's all powered by electricity. So it's possible you may lose that for brief periods of time. Hopefully it won't happen, but if it does, just realize it's the sun, it's not permanent. It'll just take a day or two to get things back going. In 1994, the FAA classified all flight crews as radiation workers. We, as aviation workers in the cockpit of the aircraft or passengers, like I said, are the most highly exposed to radiation people on Earth. So you got to understand how radiation affects you if you want to be an aviation professional. Anybody here going to go into the military and be a pilot? Planning on anybody going to the military at all? Boy, things have changed since I was young, because when I was a kid, everybody in this class would have raised their hand, because I came from a poor part of Atlanta and we didn't have any choice because we couldn't afford college. So you guys are very fortunate. You should all feel real lucky. I know you don't, but you should feel really lucky that you're not having to do that. Space weather radio blackout scales, like I said, they're 1 through 5 for the radio blackout storms or the solar storms. And S1s and R1s and G1s happen all the time. In fact, there's a G2 warning right now. But when it gets up to 4 and 5, that's when you got to pay attention, and you'll see it on the news. Let's go to the next one. The Space Weather Prediction Center. As air traffic controllers, we deal with forecasts from this place all the time. In January, me and Greg Baker and Angie Baker and several of the people that are giving you this camp all work together as air traffic controllers. We're all stressed out all the time. We're dealing with all kind of hectic stuff. In January, there was a S3 warning and a G3 warning, which means that we had to divert aircraft that were going from Atlanta to Europe or Atlanta to Russia. We had to either stop the flight altogether or divert them because the radiation was too strong. And if they flew through there, you could die, or you could get cancer, from exposure to radiation. So they take the flights that are going over the North Pole and they reroute them on southerly routes below 50 degrees latitude, because the radiation is stronger at the poles. So what you do is you take them away from that route and put them on this route. And some planes don't have enough gas to fly that way, so they just had to wait. But this happened back in January, and most people in the FAA had no idea what was going on because they'd never heard of it. I was pretty much the only person in our facility